Alright, as promised, here is me going over a few questions off the review for quadratics. So remember, this was already tested on the previous one. You can go back and watch the review or look at the answer key for the review from review 2, which I know Mrs. Hoffbauer posted a nice one. But here's another shot at it. So the first 4 questions, you're simplifying using the powers of I cycle. There's a couple different methods, but the method my class is using is to look at the division and the remainder. So if you end up with a remainder of 1, which we know looks like 0.25, so a remainder of 1 would be 0.25 as a decimal. That means it's I to the first power, which is just I. If you end up with a remainder of 2, so like 2 divided by 4 would be a 0.5, that would be I to the second power, which is, whoops, not that, is negative 1. And then if you have a remainder of 3, which would be 3 divided by 4, which is a decimal of 0.75. So I to the third power is I times I squared, so that would be a negative I. And then I to the fourth power would be no remainder, because 4 divided by 4 would go in evenly, which means you have I to the fourth, which is I squared times I squared, which is 1. So basically, your job is to remember this order of the power of I cycle, and what the remainders and what the decimals mean. So, I to the 125th power. So you take 125 and you divide it by 4 on your calculator. And I didn't really write this down, but it's something. And then the decimal is 0.25. So there must be a remainder of 1. So you're on the first level of I, which is I to the first power. So your simplification is just I. I'm going to kind of do every other question. So here, 380 divided by 4. Again, I didn't write down the full answer, but the decimal component of it is, it's nothing. It goes in evenly. Yeah. So there's no remainder, so it's like I to the fourth power, you're on the fourth part of the power cycle, and it simplifies to a 1. So it does take a little bit of memorization. However, if you could just kind of quickly derive the power of I cycle at the top of your test, if you get stuck, that would work too. That's what I have to do because I can't remember anything. Right, for 5, 6, 7, and 8, you are either adding or subtracting complex numbers together, which means you add or subtract whatever you're doing, the real parts and also the imaginary components. So starting with the real components, negative 5 plus negative 7 is negative 12. And then for your complex parts, negative 7i plus 1i is negative 6i. And then all your answers must be written in a plus bi form, so leave it like that. Next, I'm just double checking that I have the right answer. I don't. What is the right? Oh yeah, I do. Alright, number 7. Same idea. So I only see one real part in this question. However, be careful, you're subtracting a negative 5. So the real part's actually going to be a 5. And then for the imaginary part, negative 6i, be careful, this is a minus negative 2i, so it's really a plus 2i. And then plus 8i. So negative 6 plus 2 plus 8 would be plus 4i. Alrighty. And again, a plus bi form is where you stop. When you're squaring a complex number, you have to remember that it's a complex number times another complex number. So it would be awesome if you would take the time to write this out and show all your work. And some of us learn the hard way that when we skip steps and do things in our heads and try to save time and space on our paper, it backfires. So maybe don't do that anymore. You're going to distribute all the parts to all the parts. 3 times 3 is 9. And then we have negative 6i. Also another negative 6i, which do not cancel. And then positive 4i squared. So we have to keep simplifying this. For instance, these combine to negative 12i in the middle. But then you actually have 2 real parts here. You have the 9, and then this, remember what I squared is, this is really a negative 1. So this term is really a negative 4. So you have 9, and then later on minus 4. So you have a plus 5 for your real part. Beautiful. 10 is similar. I'm going to let you do that one on your own. 11 is... they don't have any sort of relationship to each other. You're just going to multiply these together. So again, we encourage you not to skip steps and do show all your work. This is a positive 32. Well, we have a negative 28i. Here we have a positive 24i. Just slow down when you're doing this question. Some of you guys were goofy with some of the mistakes you made. This is a negative 21i squared. All right, same idea. We got to combine these complex parts in the middle. But these real parts are going to combine. This is negative 21 times I squared, so this is really a plus 21. So 32 and 21 added together gives us a 53. And then negative 28i plus 24i is a minus 4i. You know, I really should be checking my work against the key. Remember, guys, your worksheet here has the answer key on the back. Oh, and the dreaded division. So when you are dividing complex numbers, you have to, if it's a binomial like these are, you have to multiply by the conjugate of the denominator, and you have to do that to both the numerator and the denominator. So, first decision you have to make is what is the conjugate of the denominator? The conjugate looks almost identical to the denominator. However, the complex part has the opposite sign. So it's still a negative 10, but now instead of plus 5i, you're going to use a minus 5i. And that is for both the numerator and the denominator. And now you need to take the time to distribute this carefully. So we're going to multiply these out. That is very not legible. Let's try that again. That's another mistake I saw from a few of us. You were inspired by my disgusting handwriting, apparently. And you were a little sloppy, and that created some mistakes for you. Alright, so this numerator, negative times negative, let's see, it's a positive 30, and then a plus 15i, and then a minus 10i. I can't read my writing, but I think that says 10. And then a minus 5i squared. We'll come back to all that simplifying in a moment. Over. Now the conjugate, if you want to skip a little bit of work, that's fine, but this is still positive 100. And then you have a plus 50i and a minus 50i. So if you don't want to write that out, that's fine. But I'm going to. And then negative 25i squared. Alright, here goes. Simplifying these. So this is a plus 5i. These cancel. And then this is a 30, yes. But this is really a plus 5 because of the I squared. So the numerator up here is a 35 plus 5i. And then in the denominator, remember this term is really a plus 25. So you have 125 in the denominator. But you can't leave it like that. You're going to need to divide each term, the real and the complex, the imaginary part, by 125. And then you're going to need to reduce these fractions. So math enter that, or reduce the fraction by hand. These are both divisible by 5, I know, so that's like 7 over, think, 25. Plus, and then these are both divisible by 5 again, so that'd be a 1 over 25i. And I know we're not letting you use a fancy calculator, so there is no math enter button, but we would expect you to reduce that back to a fraction. Alright, so make sure some of you did not put it in a plus bi form on the last test, so that's what got you in trouble. Next concept, the discriminant. Calculate it and then also know what that means. So the discriminant is b squared minus 4ac. So b in our case would be negative 1 squared minus 4 times a is 7 and c is 5. So this is 1 minus, let's see, 20, 140. So the discriminant comes out to a negative 139. But what that means for us is that we have a negative discriminant value, so we have two imaginary solutions or two non-real answers. So you can just say two imaginary solutions. I know what you mean by that. Alright, moving along. Now I want you to solve using the quadratic formula, and we're going to be a little more cautious about how we simplify and distribute and cancel. That's the issue that we were having last time. So x equals, remember it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b would be positive 4 plus and minus. B squared is 16 minus 4 times 9 times 8, and then all of it over 2 times 9. So we always encourage you guys to simplify the discriminant first. Do not square root it yet because we're going to want an exact answer. So, I have not worked this out. However, I could very quickly. I suppose I have to because I don't know what that is. Alright, so it's something negative. 16 minus 4 times 9 times 8. Alright, negative 272. Okay, so 4 plus and minus the square root of negative 272 over 18. Okay, so I know the I is going to come out with the negative, but there's got to be at least, there's got to be a perfect square in 272. So I'm going to start dividing it by some perfect square numbers. Where are we at here? It's number 17. Let's try 16. 272 divided by 16. Yep, that works. 17. So 272 is 16 times 17. I'm going to put the 16 first, and I pull the negative 1 out in the middle of it, because then when I simplify, this becomes a 4, this becomes an I, and this is just that. So right now, we have 4 plus and minus 4I square root of 17 all over 18. And this is a case where we do need to take this further and simplify, because each one of the coefficients will cancel out a 2, or divide by 2. So divide each of these by the same number, 2, and you get x equals 2 plus and minus 2I square root of 17 all over 9. The issue some of you had on your test last time was you were trying to divide just these two terms and not all three of them. So all three terms have to cancel by that common term if you're going to try that technique, which we would ask you to simplify. So let's take a look at 19, 20, yeah, 19 is a good one. Alright, so not in standard form yet. First let's subtract the 9 over. So we end up with negative 2x squared plus 3x minus 6. So going through quadratic formula, you have negative b plus and minus square root. B squared is a 9 minus 4 times a times c, and then all of it over 2 times a. Again, we want you to simplify that discriminant first. So 9 minus 4 times negative 2 times negative 6 is, I think it's negative 39. So this is the square root of negative 39. Okay, so 39 itself does not break down, but you can pull the negative 1 out as a separate radical, which means we're going to have an I in front of it. I feel like I screwed something up there. Hold on, that's not right. I'm going to come back to that in a moment. 9 minus 4 times 2 times 6. Okay, it is negative 39. I don't know. Whatever. I'm tired. Alright, so negative 3 plus and minus. This is now an I squared to 39 all over negative 4. And again, all three of these coefficients would have to cancel by something, and they don't. Some kids are thinking that these negatives cancel to a positive. Well, that's not true, because you would affect this guy's sign as well. So I wouldn't bother messing with the negatives right now. Fun fact, you actually could, but we're not going to bother with that for Algebra 2. Or no, we're in PreCalc. We're not going to bother with that for PreCalc either. You'll notice on the answer key, it does say 3 plus and minus I squared to 39 over 4. Whoops. These are the same answer, because if you canceled a plus and minus by a negative, some textbooks actually make you reverse it and go negative plus, but we know it doesn't matter. Order doesn't matter when you use a plus and minus. So either one of these answers are acceptable. Sorry, I kind of babbled on that one. Factoring. Alright, so first you must look for a common factor. 6, 43, 72. Well, 43 is a prime number, so you don't have a common factor there. So you have to kind of reverse FOIL here and think about all your options for 6k squared. So 6 and 1 and 3 and 2. Now, you might have to guess and check for a little bit. I'm going to go with 3 and 2 because that's typically the right option. And then my back numbers have to multiply to 72. Now 72 has a ton of options. 36 and 2, 72 and 1, 9 and 8, there's others. But I'm going to go with the ones that are closest together, which are 8 and 9. And I notice with my signs, they both have to be negative to multiply to a positive 72. Now I think we only have one more option here, because I can't put an 8 with the 2, and I can't put a 9 with the 3. So I'd have to switch those around if I'm going to put them anywhere here. And now I do have to go through and check. So that's a negative 27x, and this is a negative 16x. And when you add negative 16 and negative 27, you do get negative 43. Ooh, it's supposed to be k every zone, k. And another k. So that's a k. Sorry about that. So that's where, yes, it is a little bit of guessing and checking, but it's educated guessing, and you know what not to do and what doesn't usually work, and you just avoid those. All right, so these take a little time and effort. Let's see. Oh boy, 8, 20, and 100 all are divisible by 4. So you can't factor it out and then remove the 4 from the question, but you can factor it out and leave it in front of the quantity. So this becomes a 2r squared plus 5r minus 25. I don't know why that took me forever, but it did. So this has to be factored out. I know some kids were like arguing with me that, oh, I left the 4 in one of the factors. Well, you're not completely factored, so it's not okay. I'm sorry. All right, so 2r squared has to be 2r and r. 25, I'm thinking it's 5 and 5, and if I just can figure out where my signs go, I'll be good. So what if you make the 10 positive, because that's a 10, and the 5 negative? So that is the complete factorization. Last test, some of you kind of lost this number out in front, or it just went away magically. It's not an equation, so that common factor does have to stay in front, and yes, you must factor it out. All right, 25. Common factor, there is a common factor, and you should always look for it. These are both divisible by 16, isn't it? Let me do a little check in here. Nope, this is 2, I guess. Oh, bummer. All right, take a 2 out. If you took a 2 out of that, you still have a 27x to the third plus an 8. So this is one of my special patterns. This is the sum of 2 cubes, which will factor into a plus b times a squared minus ab plus b squared. So if I kind of think backwards, like who is a and who is b, a is going to be the cube root of this with the variable, so it's 3x, and b is the cube root of this, so it's 2. So the 2 stays in front, has to stay there, and then your factors are a plus b, so 3x plus 2, and then a squared would be 3x times another 3x, so 9x squared, minus, multiply them together, so 6x, and then 2 of these, so 4. Squared of that, 4. That was misleading what I said. So make sure that common factor that you're taking out does stay in front. And yes, you still need to know your difference in sum patterns for cubic. So here we're going to not just factor, but we're actually going to solve the quadratic by factoring. There's no common term. If there was, and it was a number, I could divide by it, but it's not. So we just have to kind of muscle through factoring. I'm thinking 5r and 1r is my only option for the first factor. And then 10 is probably 5 and 2, but I know not to put a 5 here, so I'm going to put a 2 here, and let's see how this goes. I notice all my signs are positive. So before I solve, I'm going to double check my factoring. That's 27 plus 2, sorry, it's 25 plus 2, which is 27. So good news, you did solve a factor correctly, and now we're going to solve. So 5r plus 2 could be a solution, and r plus 5's factor, that could be a solution. So solving this one, you're going to subtract 2, and then divide by 5. So that would be negative 2 over 5. And then this one's a little easier to solve. You just subtract the 5. All right. This one's not quite in standard form yet, so we need to add the 6 over. So we have 7a squared plus, nope, minus 6a. Excuse me, minus 6a. And then a minus 16 equals 0. So, good news is the first factor is prime. So that's 7a and a. 16 does have a lot of factors. I don't think 4 and 4 would be smart because we'd end up with a 28. I'm thinking it's 8 and 2, and I definitely shouldn't put an 8 here. Let's try putting a 2 here. And that would be a 14 with an 8. So let's make the 14 negative and the 8 positive. And that's how we're going to get 6a in the middle of our arches. So, factored correctly, and now we solve. 7a plus 8 is 0, or a minus 2 is 0. So, we get negative 8 over 7, And then we get 2 as the other possible solution. Excellent. All right, I think that was the end. I left a good half of the worksheet for you to try. I do encourage you to go and practice and go through them, especially the ones that you made mistakes on the previous test. Please look through your previous test. Look at all of our comments that Mrs. Hoffbar and I made, and don't make those mistakes again. Learn from them.